Hello again, guys. Miss Judd here. Today we're going to continue with our unit of writing equations of lines. Today our goal is to be able to write equations of lines in point-slope and slope-intercept form when given 2 points. Well, if they simply give me 2 points, I need to think about what I know about slope. So if I look at a graph, remember we once called slope at the beginning of the year the rate of change. And slope always describes the steepness of a line. It is always represented by m. And most importantly, we call it the rise over the run, or the change in y divided by change in x. And the slope formula is m equals y2 minus y1 over x2 minus x1, where x1 and y1 are a point, and x2 and y2 are a point on the line. But we can use this formula every time to find our slope without having to graph. So let's try one. Write an equation of the line in slope-intercept form that passes through the points 6, 7, and 4, -1. So to write the slope-intercept form, we're actually going to start in point-slope form. So we're going to start by finding the slope of the line. And that requires us to use the slope formula. So the slope formula said y2 minus y1 over x2 minus x1. And so I know that I'm going to have a minus in between, and I'm going to match up each of the points. So if I start with 6, 7 as my x1, y1, x1, then I'm going to put a 6 down here and a 7 up here. So this is x1, y1. And my point 4, -1 is x2, y2, because that's the second point. So in the y2 spot, I'm going to put -1, and in the x2 spot, I'm going to put 4. And then I will simplify the top and the bottom of the equation. So -1 minus 7 is -8, and -4 minus 6 is -2, which means our slope is 4. Now, once we have our slope, we can write it in point-slope form. So if I remember, point-slope form has something like this. Our slope always goes in front of the parentheses, so in this case, our slope is 4. And now we need a point. Does it matter which point we choose, 6, 7, or 4, -1? No, it doesn't. So I'm going to choose 6, 7. So behind the x, I will write 6, and outside the parenthesis, I will write +7. So that is the equation in point-slope form. And then to convert the equation to slope-intercept form, we simply distribute the 4 through the parentheses. So if I distribute this 4 through, we will have y equals, well, 4 times x is 4x, and 4 times -6 is -24, and don't forget the 7 out back. And so this would be y equals 4x. Well, -24 plus 7 is -17. And so that would tell us that the y-intercept is right here in the back, 0, -17. Write an equation of the line in slope-intercept form that passes through the points 0, 1, and 5, -4. So just like before, we found the slope of the line using the slope formula. So our slope formula, yummies on the picnic table, y2 minus y1 over x2 minus x1. And so we're going to think about our form and plug in the points we know. So our first point, x1, y1, is 0, -1. And our second point, x2, y2, is -5, 4. And then we simplify. So 4 minus a -1 is really +1. So that's 5 over -5 minus 0 is -5, which means our slope is -1. Once we have the slope, now we have a slope and a point, and so we can write it in point-slope form. So y equals, with x with a parenthesis, our slope always comes out front, and our point goes inside, so I'll use the green one again, the first point again, so -0, -1. Well, isn't that convenient? When I have a -0, there's not a whole lot of work to be done. So if I were to distribute through y equals negative 1 times x minus 0 minus 1, well, that's pretty easy because I get y equals negative 1x. Well, negative 1 times 0 is 0 minus 1, so my answer is y equals negative x minus 1. So my intercept is right here, negative 1, so it is 0 comma negative 1. Do you notice anything about that? Well, if I look back up at the beginning, 0, negative 1 is given. So I didn't even have to write it in point-slope form. I could have written it in slope-intercept form because I was given the y-intercept. Okay, you try this one. Write an equation of the line in slope-intercept form that passes through the points negative 2, 6, and 6, 5. Just like before, we're going to find the slope using the slope formula. Yummies on the picnic table, y2 minus y1 over x2 minus x1. And so, I know what my form looks like. Let's see. y2 is the y value of the second point. So y2 is right here, 5. And y1 is the y value of the first point. So that is 6. And then x2 is the x value of the second point. So that is also 6. And x1 is the x value of the first point. So that is negative 2. Then we simplify. So 5 minus 6 is negative 1. 6 minus negative 2 minus a negative becomes plus. So that would be negative 1/8 as my slope. And then I'm going to write it in point slope form. So put my x in the parentheses and leave some space. My point goes first, or my slope goes first. Negative 1/8 goes in front of the parentheses. Then I take my point. Does not matter which one I use, so I'm going to use negative 2, 6. So minus a negative 2 plus 6, which simplifies to be y equals negative 1/8 x plus 2 plus 6. And then if I want to convert into slope-intercept form, I simply distribute the slope through the parentheses. So negative 1/8 times x and negative 1/8 times 2. That would give me negative 1/8x. Well, negative 1/8 times 2 is a negative 1/4 plus 6. So then I have to combine my constants, and I get negative 1/8x. Well, 6 is really 24/4, so plus 23/4. And so that means that my y-intercept is this constant out back, so the y-intercept is the point 0, comma 23/4. At this point, I would like you to try the last few problems on your note sheet, and we'll check them tomorrow.